What you are looking at is a robotic arm that I plan to modify to use a transmitter and receiver to control, and instead of the PC or Mac application that was designed for it. This video is to establish the feasibility of making this modification, and I plan on a second video showing a demo of the modification. I'm going to first discuss the robotic arm and then discuss the prototype of the changes, and then I'm going to demo the prototype of the changes. This robotic arm was described in an article by its developer called SCARA Robot, How to Build Your Own Adreno-Based Robot. And it's on his website, www.howtomechatronics.com. I show it on the bottom of this video. This article gives a complete description and a video showing how this robot was designed and built. The step-by-step approach gave me a lot of information about the various components. Even if you are not going to build this robot, you really want to look at the video. It has a great demo. It shows the robot's complete functionality, and it really brought me to want to build the robot. The article has links to download the 3D files necessary to print most of the robots. It has other files that you're going to need, the processing IDE and the Adreno IDE software to run the robot. By the way, the SCARA, the name of the robot was SCARA Robot. So the SCARA is an acronym, and it stands for Selective Compliance Assembly Robot Arm. It also it's also an acronym for Selective Compliance Articulated Robot Arm. The video in the developer's article has such a good demo that I only want to show a small demo of a function of starting at a zero position, or home position. This allows you to consistently start at the same point. The processing IDE, I'm using P3, and its code is a great way to have user interfaces like sliders to control the robot. But you know, I am so used to using a controller, transmitter receiver to control robots and drones that I prefer having that kind of functionality in front of me. So that's the reason I'm deciding on making this modification. Okay, now this is the zero position, or the home position, so that if I record different positions of the arm and try to play them back, it'll always start back from the beginning. So this position will always be here when the robot starts up. Now, to prove that, what I want to do is to move the gripper a little bit, move the arm, move it out of the way, and show you that when I turn it on, it's going to come back to the zero position again. So it will always start from that position. Okay, what I need to do is plug it in, and we'll see it go back to its zero position. Now the Z-axis is going up to a limit switch, and when it hits the limit switch, it goes down to the same exact spot every time. The gripper position was going into its normal position. The arm goes to a limit switch and goes back to a single position. And then it goes back to the exact position we saw before. So this is the zero position. So if I have recorded steps that it goes through, it'll always start at the beginning, and it will always repeat the exact set of steps that the action that I've recorded require. In front of the robot is my hardware and software prototype that I will use to demonstrate that I can control the stepper motors, the limit switches, and the gripper's servo. In past projects, I have used all sorts of Bluetooth, Wi-Fi, and radio waves to control robotic projects. But I have this FlySky transmitter and receiver available, so that's what I'm using now. Since this is a prototype, it is kind of messy and will be cleaned up a bit when I interface it with your robotic arm. If you don't have a transmitter or receiver, the Mechatronics website also has a good project that shows how to build an Arduino-based transmitter and receiver. I put together several components that I like. In this module I call the LotBot based project. I use it to test and receive data from a FlySky transmitter. I recently created a third iteration of this project and an associated video about it, so I wouldn't have to spend too much time in this video describing it in detail. If you're interested in this module, that video, I put the name on the screen. You can find it in my YouTube channel, LotBot Robotics. Now I'm going to tell you what these electronics are doing, and then I'll give you a demo of this prototype. Well, in the video, I describe the fact that this module has two black pills and they're talking to each other via I2C, and there's a multiplexer here that allows me to talk to two screens. And in addition, and these two are the receivers. They're 8-channel receivers. The transmitter puts out 16 channels, and the switches and knobs are on this one, and the gimbals are on this one. For this particular project, I'm only using this one and this one black pill. Normally, I would have this black pill receive the data from this receiver, and this black pill receive the data from this receiver and talk together. But this is all described in another video. The key thing is that coming out of the back here is I have two wires, which is an I2C connection. It's a bus that goes to this other black pill over here. Now, what happens is the data from the transmitter gets picked up on the receiver, and it's sent over to this other black pill. And this black pill is the one that really controls the stepper motors and the servo and the little limit switch. So what happens is well, I have a 12-volt power supply here that goes on this bank, and there's 4 stepper drivers here that connect to the stepper motors, and they power the stepper motors with the 12 volts from that power supply. And however, they communicate with the black pill via 5 volts. So I have this little converter here that takes the 12 volts and gives me a 5-volt bank here. And that's what's powering the black pill, and that's really it. That's what powers the black pill. What also powers this little, this is a voltage meter that tells me how much voltage I have on this. And I have a little voltage meter over here also that shows the 12 volts. You'll see this in the demo. And that's basically the, oh, by the way, these stepper drivers here, there's an excellent tutorial that tells you how to use it, everything about it, on that website I've been talking about, the Mechatronics. They have an excellent tutorial describing them. That's where I picked up all the information I know about it. Well, that's basically the electronics. I want to show you a demo now of the transmitter sending out data and it being received by this module and picked up by this black pill and then it does whatever it has to do. The one neat thing, though, that I didn't mention is that in that other video that describes this module, there's two displays here. And you'll see that the information related to how I'm changing the steps on the stepper motors is going to be displayed here, and I'll point it out. Oh, one other thing is that I have in this module that I like, I also have a little SD card, SD adapter here, so that I can record the steps that the robot takes, so I can play them back, and we have a repetitive type of sequence, because this always goes back to a 0 point, which I showed you in the previous demo. I'm not sure whether I'm going to leave this SD adapter here, or use this SD adapter here, or connect one directly to this black pill, because the data is here that it's really using to move the stepper motors and the servo, as well as using the limit switch. The other thing is this is how the code is loaded to the black pills there, and this is used to load the code to the black pill here. So during the actual execution of this, I don't really need this, and I don't really need this, because all the code will already be in the black pills. So this is sort of self-contained. Now let me show you a demo of these things actually working. Well, I've rearranged the board so that I could demo things a little easier. I'm also holding the camera because I have to get in close to a few things, and I can't really do it from a tripod. One thing I do want to show you right off the bat, unfortunately this is going to be a little jumpy, is this. I took the two USB to serial adapters off of the boards, because I no longer need to load a program to the two black pills here, or this black pill over here. Also, I mentioned that you're going to see the voltage indicator over here. This one's showing 4.99 volts, and of course it's coming from this converter over here, where this bar here came in at 12 volts. Right now, when the system starts up, the left screen shows that it's set up to select a specific stepper, so you can see the stepper move based upon the number of steps. And over in the right screen, you can see that the four stepper motors are set for 0 as far as the software is concerned. If you remember that I did the demo that shows that the arm would be in a 0 position, having the four steppers at 0 sort of implies that. And this, so now I want to show that I can move these stepper motors. I've got them right here. Now, in order to move them, let me just show you this. I'm using these four switches. This is A, B, C, and D for the four stepper motors. So if I click on, well, just can't see these two together. This is Z, or the fourth one. So if I click on this, I'll be clicking on that, and you'll see that here it selects the stepper motor for Z, this one right here, and it shows it's set up for the number of steps is 1. Now this knob over here changes the number of steps. So if I turn this knob, you'll see that the number of steps goes from 1 to 5 to 10 to 20 to 100. Now I'm going to leave it at 100 because when I'm only doing a step of 1, then, you know, like say on here, you'll see this thing move like that. It won't even be noticeable. But if I do 100, it'll move quite a distance. So in order to show you that it's actually moving, I'm going to use 100. Also, I'm not going to use the Z because I want to be able to be close to the switches over here. So I want to use this. One over here, which is stepper 1. And that way you can see the screens and you can see the movement at the same time. So I'm going to turn on the switch for stepper 1, and you notice that it comes out with an error message because I left the switch on for stepper Z. So I'm going to turn that one off. It goes back to 1. Now it's set up to go clockwise. If I switch, it's a 3-way switch, so one switch gets me clockwise, 2 switches goes counterclockwise, so it'll either go in one direction or the other direction. So I'm going to put it back to clockwise, and then I'm going to hit just a little lever here. I'm using this lever right here, and if I hit that, you see it moved the stepper motor. At the same time, you see that the S1 in the second display is now 100. And if I hit it again, it goes to 200, and it moved again. And then if I change the switch 1 to counterclockwise, remember it went one way, and then if I hit the lever, it goes the other way. I hit it twice, I'm sorry. Let me just hit it one more time. You see it goes negative 100, and if I put it back to clockwise, it'll go positive 100, and it goes back to 0. So you get the movement of the stepper motors. The knob over here will take me from the movement of the stepper motors to the movement of all 4 motors. So if I move the knob just a little bit, let's see, I'll just move it a little bit, and it goes to where it moves all of them. See, now it's in a continuous stepper movement. So that shows that I can control the stepper motors pretty good, both clockwise, counterclockwise, and continuous rotation. And then if I move that a little further, okay, and then I have to hit the, I have this little switch over here. Once it's on the servo function, if I hit the switch one time, it'll make the servo move. So, okay, that's moving. And then on the screen, you can see it says move server to open gripper. Now, if I flip it again, you'll see that it moves the opposite way. And that says that it moved the server to close the gripper. And the server goes one way to open the gripper and moves the other way to close the gripper. I need to go back to the continuous flow, because what I wanted to do was to show you that the limit switch, where is my limit switch? Oh, there it is. The limit switch over here, if I have to bring it up. If I close the limit switch, you'll see that it picks up the fact that it closed, and it moves the stepper motors the opposite way. So I let loose, close it again. Okay, so you do see that this is set up to be able to control the stepper motors, control the servo, and can pick up the limit switch. So that's the demo of the everything I wanted to show you. If there are any questions about any part of this project, please put them in the comments and I'll try to respond. If you're interested in this project, I will have a second part of this project in a video in the future, so check back often. Thanks for watching.